All right. Number 2, we're going to talk about just-in-time engineering. We've heard the phrase just-in-time manufacturing. You're maximizing your return on your investment by minimizing the inventory that's hanging around your warehouse. Al, what do you think is going on in this picture over here?
Looks like a big parking lot, possibly a raceway.
It is. That's exactly what it is. This is Nissan's test track where they test out new cars, but this is it during 2009 when the credit bubble imploded. Their factories were still working at full capacity, churning out cars, but they couldn't find anyone to take the cars. They couldn't find anyone to ship them. They couldn't find dealerships to take them. They couldn't find people to sell them to. And so they ran out of space on their parking lots. You can see a parking lot way back here. But they started parking their cars in their test track. And if you look at all these cars, this is millions of dollars of work. Each one of these little dots is a car. This is millions of dollars of work that Nissan has invested, sunk in, but hasn't gotten paid for yet. This is what just-in-time manufacturing wanted to solve, is all that inventory you're carrying is sunk cost. So have the inventory show up or be made right before the next person in the line needs it. You don't want the next person in the line to wait on your inventory. That's a cost as well, him being idle. But you want to show up just in time. So just-in-time manufacturing kind of swept the industry. So a lot of folks are using it now.
I have to say they made a pretty neat pattern.
Yeah, it is. It looks pretty nice from space. But some of these cars you can't even move. I don't even know how you'd get them out of there. But that's just-in-time manufacturing. So most engineering managers have some sort of Gantt chart or some sort of chart like this in terms of drawing completed. And they have it broken up by subsystems. So you can see that this subsystem, they're 0% done. They're kind of the slackers. This one's just getting started. They're 20% done with their drawings. And this one down here, this subsystem's ahead of the curve. They're 100% done in their drawings. They sound like they're really got something going on. But if you think back to that chemical factory example I used in the beginning, what if the names of the subsystems were like this? Documentation hasn't started. The reaction control system just got started. But the gas delivery system, they're 100% done. We've sized our tank. We've got the huge tank ready to go. All the drawings are done. And then you figure out you need 500 times less gas than you thought. Now the picture changes a little bit, doesn't it?
It does.
All right, so that's because of things like that. I read this pamphlet. There's an engineering manager survival guide from Lifecycle Insights Novell. He talks about an idea called just-in-time engineering, saying making engineering decisions too early is just like having inventory that's costing you money. What does he say in this pamphlet? Figure out what design decisions are important to you, what's changing what's driving your design, what's most important. Figure out the last possible time you can make that decision based on lead time, and then don't make that decision until then. In this case, it's the size of that gas tank, right? The size of the gas tank wasn't driving the design. It's how fast was the reaction going? How fast was the gas being used? So don't make a decision on how big the gas tank can be until you know how much gas is used, right? So what does that mean? Let me go back one. Just managers want metrics, right? There's a big drive for metrics. The vice president wants to see metrics on every division, so you have your engineers make metrics. Managers still want to see if their engineers are ahead of schedule, behind schedule, and a lot of people are still using that drawings completed or products released or parts released mode. What the guy in the pamphlet said is, track your progress with iterations, not drawings released. How many iterations have your guys gone through? This is an example of an oven we made for some customers, and because we made it, I can use the heck out of this design. I don't have to hide and pretend. So there's an oven, and we're putting on the shipping floor. They're putting one oven on top of each other. And one thing you can do right away in iteration 1, if you do that simulation test, you can tell the oven's going to buckle. It'll crumple just like the thin sheet metal piece it is. So iteration 1 taught you that. In iteration 2, you test out different designs to make the oven not buckle. Maybe there's some sort of thick Russian girdle type design, or maybe a thin where you use these existing supports, you just weld them to the back face. So you try that out in iteration 2. Both of them solve the buckling problem, but maybe one of them is stronger than the other. And in this case, the Russian girdle is stronger than the extra supports. So maybe in iteration 3, you start testing out how big should that Russian girdle be. And iteration 4 and 5, you're kind of fine-tuning it. You're kind of changing the dimensions of it. All right? This is the way that they're saying to track progress. How many iterations have you gone through for this design? Maybe each, excuse me, maybe each iteration has a different point. Maybe one is to reduce weight. Maybe one is to reduce buckling. One is for usability. One is for manufacturability. Maybe iterations have multiple points, right? But as long as you know what each iteration is designed to learn and designed to improve, go through those iterations, and that's how you can track your progress. You can see if you're ahead or behind schedule based on how many iterations you've gone through. Does that make sense, Al?
It does.
All right, very cool.
It reminds me of my designing days.
Yeah, I mean, this is what we learned in engineering college. You know, the iterative workflow, kind of spiral workflow. But putting it into practice is what we're talking about. You know, it's hard for some managers to let go of their progress bar type metrics.
Absolutely.
All right. So what else? No one's really heard of Lifecycle Insights. Not a really well-known name. If you Google just-in-time engineering, you're not going to find a lot of hits. It's still kind of a new idea. People are still kind of wrapping their head around it. So how do we make sure we're not going off in a strange way? You know, how do we do some sort of sanity check to see if this is a really viable idea that's not just crazy and wishful thinking? Well, there's this book out there called Lean Startup. It was released 2 years ago. It became a New York Times bestseller. Some people are calling it the best business book of 2011. I was reading it just a couple weeks ago. And so this number has gone up, this 990,000 number has gone up at least by 1. I was reading it a couple weeks ago, and what he talks about is a build, measure, learn cycle for startups. He's trying to figure out why some startups fail and some startups don't. And he talks about this build, measure, learn cycle. And Eric Ries is saying the thing that determines whether a startup fails or doesn't is how fast they can go through this cycle. In fact, the whole goal of a startup is to accelerate that build, measure, learn cycle as much as possible. A lot of startups spend most of their time in the build phase. They're trying to get every bug hammered out of their system. They want their product to be perfect and not fail in any way. They're going to protect their brand reputation, right? And they do that, and they release a product that no one wants, or it has some sort of fundamental marketing flaw or some sort of fundamental design mistake. If you go through this build, measure, learn cycle and see what the customers think about your products every single iteration, you learn so much. You can make these little course corrections, and then you actually make a product that people want, right? But he was talking about maybe code or maybe prototypes. But if you think about going through this cycle with virtual testing, just like we did with the oven a second ago, right? That's where you can track progress. That's where you can really make some profit and find a blue ocean while confident that it's going to be there. All right? So a great book, Lean Startup. I highly recommend reading it. It's actually become a movement. There's Lean Startup meetings in Boston, I think next week or coming up. It's become a whole movement across the country. So, and a startup doesn't have to be two guys in their garage. Fortune 500 companies, if one division is trying to put out a new product, a product that hasn't existed before, maybe a blue ocean type product, they're a startup. They're working on the basic same constraints a startup has. They need to accelerate this build, measure, learn cycle, right?
So it makes me think of Hyundai cars. I mean, Toyota and Honda have been around since the 50s or earlier, and Hyundai came out in what, the 90s, maybe 80s, and from the inception of the Hondas and the Toyotas, they were crappy little cars way back when. Now they're like high-end.
Right.
Hyundais, when they first started, they were crappy little cars, and look at them now. They're right up there with the kings. So
yeah,
just makes me think of that.
Yeah, no, it's all learning. Like one company that I think it was Nissan. I'm still kind of 3/4 of the way through the Lean Startup book. It talks about when Nissan wanted to make a new van, they sent one of their product managers over to America, and they had him drive around the country talking to people in vans, and figuring out what they wanted. And he figured out that it's really the kids that decide what minivan gets bought. The kids are the ones who occupy 3/4 of the minivan in the back. They're the ones who are spending most of the time in it. And so they put a lot of kid-friendly features in their new minivan. But yeah, it's iterations. It's testing those little ideas out.